CS3451 Introduction to Operating System. Topic is Memory Management, Contiguous Memory Allocation, presented by Anuja or APCSC, Rohini College of Engineering and Technology. What is memory management? Program must be brought into memory and placed within the process for it to be run. Input queue, a collection of processes on a disk that are waiting to be brought into memory to run their corresponding programs. And also user program go through several steps before being run. Address binding of instructions and data to memory address can happen at three different stages. One is compile time. So compile time is if the memory location known a prior, absolute code can be generated. It also must recompile code if starting location changes. Load time must generate relocatable code if memory location is not known at compile time. And third one is execution time, binding delay until run time. If the process can be moved during its execution from one memory segment to another. Need to hardware support for address map, for example, based on limit registers. Then swapping. So the swapping is the process of temporary out of memory to be packing store and then brought back into memory for continued execution. Backing store. First disk large enough to accommodate copies of all memory images for all users and also must provide direct access to these memory images. Rollout and roll-in. Rollout and roll-in means it is a swapping variants used for priority based scheduling algorithm, and also lower priority process is swapped out so higher priority process can be loaded and executed. The major part of swap time is transfer time. Total transfer time is directly proportional to the amount of memory swapped, and also modified versions of swapping are found on many systems, that is Unix, Linux and Windows. So this is the schematic representation of swapping. Then contiguous allocation. Main memory is usually into two partitions. Residence operating system usually held in low memory with interrupt vector. User processor then held in high memory. Single partition allocation. It is reallocation register scheme is used to protect user process from each other and from changing operating system code and data. Relocation register contains the value of smallest physical address. Limit register contain range of logical address. Each logical address must be less than the limit register. Multiple partition allocation, that is whole. Whole is nothing but a block of variable memory and the wholes of variable size are secreted throughout memory. When a process arrives, it is allocated memory from a whole large enough to accommodate it. The operating system maintains information about allocated partition. The second one is free partitions. So this is the diagrammatic representation of multiple partition allocation. The next one is paging. A logical address space of a process can be non-contiguous. The process is allocated physical memory whenever the letter is available. Divide physical memory into fixed size block called frames. The size may be with 2 between 512 bytes and 8192 bytes. Divide logical memory into blocks of same size called pages. Keep track of all free frames. To run a program of size n pages, need to find n free frames and load program. Set up a page table to translate logical to physical address. Handle external fragmentation and also is to internal fragmentation still a problem. Address generated by CPU is divided into two parts. One is page number and then one is page offset. Used as an index into a page table which contains the base address of each page's physical memory is called as page number, and it is combined with base address to define the physical memory address that is sent into the main memory unit is also called as a page offset. So this is the diagrammatic representation of page. paging example. Then implementation of page table. The page table is kept into main memory. It contains two parts. One is page table or base register. Then second one is page table length register. The page table base register is point to the page table. The page table length register indicate the size of the page table. In this scheme, every data instruction access require two memory access, one for the page table and one for the data instructions. The two memory access problem can be solved by the use of a special fast lookup hardware catch called associative memory or translation look-aside buffer. Page table structure. A page tables need to be small for fast access and keeping them in main memory. The large virtual address space may require a very large page table. Hierarchical paging. Hierarchical paging is nothing but break up the logical address space into multiple page tables. A simple technique is a two-level page table. One is hash page table, second one is inverted page table. The two-level paging example, a logical address on 32-bit machine with 4K page size is divided into a page number consisting of 20 bits, a page offset consisting of 12 bits. Since a page table is page, the page number is further divided into a 10-bit page number and 10-bit page offset. Thus, the logical address is as follows. So, this is a page number. This is a page offset, where Pi is an index into the outer page table and P2 is the displacement within the page of the outer page table. Thank you.